Good afternoon, everyone. Thank you for joining us for this webinar today on what is a beautiful spring day here in Newark. I hope it's nice where you are. I'm going to move to a slide that'll show an outline of what we're going to talk about today. Some of you may want to know what is data envelopment analysis, so we'll talk about that. We'll talk about how DEA, as its short form is, can provide a best practice virtual academic department that you can use as a guide for improvement towards efficiency. We'll talk about how you can select the best comparator group to use for data envelopment analysis, and how you can take some of the metrics and combine them into a standard kind of visualization. How we've combined multiple years of a DEA analysis to kind of show a trend. And then also we can talk about how DEA benchmarks can be complementary with the existing sort of standard cost study metrics. My plan is to just talk through the presentation without any questions, and then towards the last 5 or so minutes, we'll talk about questions. And if you have a question that you'd like to interject during the presentation, please use the chat option. Just type in your question, and I'll try to address it on the fly as we move through the slides. So here we go. Thanks again. So here are the variables that we're going to talk about in today's presentation. Many of them are familiar to you. How many tenure or tenure track faculty are in a department? How many other types of instructional faculty are there? How much money does the department spend on instruction? How many credit hours are taught by faculty at each level? And the various levels that we'll focus on would be undergraduate lower division and upper division, and also individualized instruction provided to undergrads, and at the graduate level, and also graduate individualized instruction, which tend to be more dissertation or research hours, as opposed to study, independent study, which you might find among undergraduates. So what is DEA? Well, it's a application of linear programming in which you use a number of variables to provide what it would be a relative efficiency comparison. In other words, we'll take all of the data in a group, and using the most extreme points, map out a data envelope or efficiency frontier. And that can show us how each of the members of the group compare to one another. And it also allows that you can create a single number to express efficiency on a scale between 0 and 1. So the efficiency frontier is mapped out by the most productive of the individual departments. And of course, we'll be comparing departments in the same discipline. For instance, we'll be looking at an example among all English departments that were in a particular subset of our 2015 data. The efficiency frontier is useful, but the efficiency number can kind of summarize a sort of multi-dimensional view of what the department's doing, taking into consideration both inputs and outputs. Now, in DEA, there's a lot of applications of DEA, some of which maximize output while keeping input constant. That's the approach we're going to look at today. You can also minimize input and try to keep output constant. So that would be used in a more cost-cutting type of application, which we don't think is really appropriate for our data. There are models which use both at the same time. They all kind of share the same characteristics, that they develop this single number that expresses efficiency on a scale from 0 to 1. And the inputs are all weighted based on their relative distance to each other in a sort of dimensional space. I also would say that in respect to the efficiency numbers, it's not a linear scale, so you can't say that a department that's operating at a 0.5 efficiency is half as efficient as one that's at 1.0. What you'll see in this presentation is that there are many ways to reach efficiency, and that often in a comparator group, there may be half of all of the departments are efficient relative to each other, but getting there in different ways. So it's not a one-size-fits-all or a linear scale, but I think an illustration will help to explain what I'm saying in a more concrete way. So let's suppose that we take 3 departments, and in the vernacular of DEA, they're referred to as decision-making units. So you'll see that abbreviation DMU several times in the presentation. Let's say these 3 departments each start out with 100 hours of faculty teaching effort. And the first one, Department A, orients that all towards undergraduate, say 40 undergraduate students and 0 grad students. Department B uses the same resources but focuses on 20 undergraduate students and 5 grad students. And Department C focuses on 10 undergrads and 20 grad students. So if we map out these 3 points, you'll see that on a 2-dimensional scale, we can plot those. And then we'll form a data envelope using segments that go from the vertical axis over to the highest most point on the in the quadrant, and then down through the most extreme point towards the other axis, the horizontal axis. So we can see that there's this data envelope formed, and you can see that Department B is inside the envelope. So we would deem that A and C are on the efficiency frontier and B is inside the data envelope. We can then draw a path between the axis, the origin that is, through B to the efficiency frontier or data envelope, and we can calculate the length of the segment that goes from the origin to point B, and also the length from the origin to point E, and this would map out the virtual path towards higher efficiency for Department B. And as you can see, hopefully the balance of student teaching would go towards about 29 undergrad and 7 graduate students if Department B was going to reach the same level of efficiency as Departments A and C. Now, of course, this is a 2-dimensional world, and we're not really plotting out the inputs here or differentiating them in any way. Another illustration will be helpful in sort of showing what it looks like when you're using actual data. So we're looking at a 2-dimensional plot again, but this time the red dots represent actual data points. These would be actual departments of a similar type, let's say English departments. And you'll see that most of them are on this data envelope, and there are 2, P sub 5 and P sub 6, or Department 5 and 6, that are inside the envelope. And we can map out a path towards the data envelope, which is labeled P sub 5, and it's kind of colored blue if we go directly from the origin through Department 5's data point and then on to the envelope. But sometimes there are constraints that will not allow us to go directly in that straight line. So there is another path that can be calculated for Department 5 to reach efficiency, and that one's the green data point. So there are possible ways to reach the data envelope for Department 5, given that possibly there could be constraints in some dimension that prevent 5 from going directly to P sub 5. So that's conceptually what we're talking about when we talk about a virtual best practice department. So let's talk about the Delaware study data and how this is used to create a DEA model. First thing we want to do is talk about the assumptions that are going to be used governing building this model. In the first place, we assume that tenure-track faculty are different than other types of faculty. That is, tenure-track faculty are generally going to be at an institution for a very long period of time, and are going to assume a certain institutional role relative to any other kind of faculty. They serve on committees, they kind of build the reputation for research, and in that regard, they often carry lower teaching loads than other types of faculty. Now, we'll also assume that there's no difference between credit hours that are taught between faculty types, that credit hours are kind of like dollar bills in a sense of each one's worth the same amount. However, they're not necessarily interchangeable. So if you teach credit hours at the lower division for freshman and sophomore courses, that's not really replaceable with graduate level instruction or vice versa. So they're different than each other in a qualitative nature. We're also going to assume for the building of the first model that we're going to look at that the department's ability to obtain grant-funded either research or service funding to provide public service or to do scholarly research that goes above and beyond what the university or college funds is a indicator of their distinctiveness in the ability to do research. You might quibble with that quantitative measure, and I think we would understand that, but it is an element of data that we have available and that we think are meaningful in the distinctions that can be drawn. So if we look at this first model that we're going to build, we see there's 3 input variables. Tenure track faculty would be one, the FTE associated with that. And then all other faculty. Now we exclude the teaching done by teaching assistants if they are not instructor of record. So the non-credit bearing TAs would be excluded from this model. The output variables are the teaching of the credit hours at various levels. So we have the lower division credit hours, the upper division, the individualized instruction for undergrads, the grad credit hours, and the graduate individualized instruction. So a total of 8 variables. Now, there's some prerequisites for using data envelopment analysis, and it depends on having data from very similar departments. So there's a number of ways that you can decide for a subset of departments that are alike. One would be to use the Carnegie classification. However, we know that sometimes an institutional Carnegie classification does not equal the reality in a department. So you might have a research institution that has a department that's teaching anthropology, for instance, and only offering a bachelor's degree. So in that case, you have to do some work to align the group that you're comparing in DEA with the other departments of the same type. So one of the ways that you can do this is to use the highest degree that is awarded by a department, or you could use the proportion of undergraduate to total degrees awarded in place of Carnegie designation, or you can do a more sophisticated or conventional in a sense. You can select peers that you think are the most liked based on reputation and rankings. We used an approach in this example which said, let's let the data help us, and we used a structural equation model to obtain a peer group, and we'll show you that in a few minutes. But there's no one perfect method of getting a group that you want to use for comparison in DEA, other than you know that the group is alike the other departments in important ways in terms of its instructional mission and maybe its size and the type of degrees that are awarded. We're also going to suggest that using longitudinal data is often useful because sometimes you get some smoothing of year-to-year noise that occurs when you're measuring productivity or cost. As far as how you can implement DEA, we're going to use models that were run in R, but we initially started using SAS for the development of models, so you can use SAS. You can also use Stata, and I'm sure there's many other options that are maybe less well-known software packages, but I just thought it was worth mentioning that we used R because we wanted to make this accessible. If you were interested in doing this on your own, we can share the code. It's handy that way, and then of course you can use other R functions to take the results and put them into visualizations. Now, before we show you an example, I just wanted to mention that we did use a somewhat involved method to obtain a similar group for comparison when we developed this particular model. We started out with all of the participants that provided data for a 4-year period in English, and then we used a method to assign each of the 15 participants, of which there were 174 in the cost study, to one of 4 groups. And we'll be looking at one of those groups that had a size of 31. And we're convinced that this is a good comparator group. We've done several validation checks on it, and we think it's a good group for comparison. It looks like this. It has the 31 members are mostly research high or highest institutions. There are a few exceptions to that. There are several in the same state, which we highlighted in different colors here. And as I said, I think we were convinced by external feedback from English department chairs that this was a good group for comparison. Now, if you look at the results of the DEA model, you'll see that here I have listed all of the members of the group that were on the data envelope. So you'll see that they have an efficiency number of 1. And you can see that in the column under TT faculty, we tried to list this from smallest to largest. So there is a range of faculty sizes. Of course, you'll see if you examine the combination of tenured faculty and then all other faculty that there is a variety of departmental sizes and configurations, some of which lean heavily towards the tenured faculty and have only a few other faculty, and some of which go in the opposite direction. And again, this mirrors the idea that there's no one perfect path towards efficiency, but what you would want to do is tend to focus on departments that were maybe similar to yours in size and budget. So what I've done is to say, let's take these 16 that are on the efficiency frontier and compare it with 2 that are inside the data envelope that have relatively similar efficiency numbers, and they're down on the last couple rows there with efficiency numbers of 0.837 and 0.836. Now, for a more specific comparison, let's take a look at how they look compared to each other, and also compared to one of the ones that was on the efficiency frontier. So you'll see that all 3 of these are from research highest institutions. The number of degrees that they award is in the same ballpark, a little higher than the overall average for the entire group. You'll see that I'm sorry, that's undergraduate degrees that are higher. When you combine grad and undergrad, they're a little closer to the average. But the faculty size, particularly the tenured faculty, are in the range between 28 and 37. So there's some variability in the number of tenured faculty here. But what you'll note that our regular cost study metrics is the cost per student credit hour. 2 of them are at about 285 and 257, which is roughly twice the cost per student credit hour of the one that's used as a comparison that's on the data envelope. So you can see efficiency in that number right there. You can also see that the amount of sponsored research and public service for the tenured faculty is about 5 or 6 times as much in the most efficient one of these 3. So it gives you a good idea of how you can find 2 programs that are similar to each other, but are not nearly as efficient in their overall output as the one that's on the efficiency frontier and is similar in size. Now, as I said, we can also develop this best practice DMU, and here's a look at what it would appear like as articulated by the 3 efficient programs that contribute weight to the development of this best practice virtual DMU. And you'll see that the virtual one has the same number of tenured faculty, same number of other faculty. It actually shows that this could be done at a much lower cost. Now, we're not going to suggest that you could cut $3.5 million from the budget, because that's not realistic based on the constraints that exist for having tenured faculty and working in a particular region of the country, and also just simply the cohort age of a faculty sometimes dictates that it gets paid much more than a faculty with a less senior membership. But what we can do is say, okay, how do we compare the credit hour productivity with this department and its best practice virtual department? And you'll note at the bottom line, there's several noticeable differences. The one in which they're the closest would be graduate level student credit hours, which the differences between the actual and the virtual are 110 student credit hours. Now, this is based on a fall semester accounting, so that would be about 12 additional grad students if we were going to reach this efficiency level. So what would that mean? Well, you can compare this to the traditional standard metrics that are available in the cost study. What you'll see right there on the screen is kind of a schematic view of the web portal with page 1 where we do data entry and page 2 where you can see benchmarking results. And so let's zoom in on that a little bit. And what we can see is that the faculty in this department are teaching about 7.5 grad credit hours, that is the tenured faculty, versus a 3-year average of about 20.5. And so if you go down to the bottom and combine all faculty types, you can see that there's a difference of about 6 credit hours per person. If you go back to the tenured amount, certainly there's room within the 31 tenured faculty members to take on about 12 new grad students, provided that the resources were available and the recruitment was successful. So we know there's always constraints on anything that you suggest that could be done. But again, to look at our standard metrics, you can see that the current cost of $285 for this department compares to a 3-year average of $208, which is kind of in line with what we've learned about averages over time for credit hours. And so there's an argument to be made that this department could benefit from adding additional teaching, which would, if the budget remained the same, would lower the cost per student credit hour. Now, another variation on the models that we created in DEA come when you're looking at master's or baccalaureate programs. And we're not going to have time to go into great detail about the examples, but if you are interested, I will make a PDF of this whole presentation available. And as an appendix, we have 2 examples that use what we call Model 2, which is aimed at master's programs that don't have doctoral degrees, and then Model 3, which is aimed at bachelor's degrees. Now, the reason these different models have been developed is to take advantage of the available data. Here's a comparison of 4 model types, and you can see down at the bottom a listing of the sample size that you need in order to run a model. So for Model 1, we need 24 comparators. For Model 2, which differentiates more between the teaching done by the tenured faculty and other faculty, you need 39 observations. Model 3 doesn't have any graduate hours involved, but you can differentiate between the types of undergraduate teaching done by tenured and other faculty. So it requires 27 observations. And Model 4 we haven't used very much. It is based on situations where data is relatively sparse and we only have 12 observations. Now, I promised a little bit of a comparison with 3-year averages. I'm sorry, not 3-year averages, longitudinal averages. And we're going to use the box whisker plot to do that. So this is the sort of generic box whisker plot for your reference. And here's what it looks like if we say, let's take 5 key performance indicators and we look at the faculty size as one of them. We look at how much it cost, and you can see in this box whisker plot that the profiled biology department has a relatively small faculty of 14.8 faculty members, and their cost is around the median level of about $221 per credit hour. You can see that this is a wide distribution. Those little orange dots represent individual departments within the comparator group used in DEA. Now, this is an efficient program, and it's kind of mirrored by the other 3 metrics that you'll see displayed as box whisker plots. The lower division student credit hours is well above the median and relatively close to the 3rd quartile. But their upper division productivity was not as high. They were down at the 25th percentile, but for graduates, they were well above the Whisker and in the position of almost an outlier for the distribution. So what it says is this is an efficient program on the 5 dimensions that we talked about, because with a relatively small number of faculty at a modest cost relative to its peers, it's able to distinguish itself in lower division and graduate student credit hour productivity. It also shows that there's probably room for some change in the mix of credit hours that are offered. You have the perhaps less emphasis on maybe the graduate teaching and a little bit more on upper division would be one possibility. But of course, that's a curricular decision that would be left up to the department. If we look at a more longitudinal view, here's another similar comparison for a department over 3 years. Now, this is a computer science program that each year had a relatively good efficiency number, but not 1, so they've got some room for improvement. And you can see that in terms of expenditure per credit hour, they are either between the 25th or 50th percentile. The faculty size is relatively small, again, between the 25th and 50th percentile. But each year they had sort of a different profile when it came to teaching. The first year in lower division, they were at the median, and they moved up towards the 3rd quartile. And then in the 3rd year in 2017, they're down below the 25th percentile. So this may be a reflection of some fluctuation that indicates, lack of stability or a lack of demand for classes. But what it allows you to do when you're talking with a department chair or dean is to say, okay, we've got a fairly comprehensive picture of the cost and activity on one slide or one set of graphs that spans 3 years. So it really provides for a rich discussion of both trends and for future planning. Now, unfortunately, we're at the close of the end of our 30 minutes, and I promised to keep it within 30 minutes. So what I would say is 2 things. I'm going to kind of make a plug for you to tune in on April 25th. We want to talk about the research that we've done and the findings through the Education Policy Initiative, which are our collaborators from the University of Michigan and the University of North Carolina at Chapel Hill. There's this Market Watch article does a very nice job of summarizing the results with some great graphics. You can take a look at that by visiting this website if you're interested. And again, I'll make this presentation available as a PDF, either directly through email, or we're going to put it on our homepage when we get a few minutes. And just as a final note before we open it up for some discussion, there is an appendix that will give examples of both Model 2 and Model 3 The Model 2 example is an accounting program or a department that awards a master's degree as the highest one. And we'll show you kind of some features of the data. Here's a display of some of the results of the data envelopment analysis. And then we also have a Model 3 example that uses bachelor's degrees as the highest one awarded. And again, we'll provide some additional data that you can use to take a look at both the data envelope and the best practice for one example. Now, I'm going to unmute everybody. So if you'd like to talk, or if you have a chat that you'd like to just type in your question or comment, we're open for discussion, and we can move back to any of the other slides if that's helpful. I do want to thank everybody for their participation and not only your participation here, but also your hard work in support of the cost study. I know some of you are probably looking forward to being finished with your data entry and getting results. So do we have a question? Maybe that after lunch, everybody is just content to sit back and contemplate. Well, I want to, again, thank everybody. And I guess unless we have a late question coming in, we'll call it a day and wish you the best as you move into the late spring and early summer. We will be sending out a preliminary set of norms in mid-May. And that preliminary set will allow you to do some fairly early planning or budgeting type work. The final results should be available in late June. But if you have a need for data earlier, please let me know. As far as the peer analysis option goes, that will probably be available also in late June. But again, if you have a specific need, don't hesitate to ask. And I guess with that, I will bid you all good afternoon and thanks.